Hello everyone, I am Deepak Dureja and I have been taking CAT classes for the past 18 years and the topic of the video today we have is coordinate geometry part 3. So we'll be primarily focusing on straight lines. Let's have the overview of the session. So we'll be starting the discussion with forms of straight lines and conditions for parallel lines and perpendicular lines, followed by some basic formulas used in straight lines with examples, and lastly we have some practice questions and their answer key. So this is the first form of equation of a line, the point slope form. The equation of a straight line passing through the point x1 y1 and having slope m is y minus y1 equals m into x minus x1. So let's have a question on this. Determine the equation of a line through the point -4 -3 and parallel to x-axis. Obviously, if the line is parallel to x-axis, its slope would be 0. So the formula y minus y1 equals to m into x minus x1, and straight away we put the values. Y1 is -3 equals to 0, straight away gives us the answer as y plus 3 equal to 0. Moving on to the next, this is the answer. So we have 2-point form. The equation of a straight line which is passing through the points x1 y1 and x2 y2 is y2 minus y1 upon x2 minus x1 equals y minus y1 upon x minus x1. Let us use this and try to solve this question. Find the equation of the line joining -1 3 and 4 -2. So we have the formula. It says y minus y1 upon x minus x1 equals to y2 minus y1 upon x2 minus x1. Let's put the values. So we have y minus y1, we have is 3. We can just write the points. This is x1 y1, this is x2, and this point is y2. So let's put the values. So y minus 3 upon x minus x1 we have is -1, so this would become +1 equals to y2 is -2 minus y1 is 3 upon this x2 we have is 4 minus x1 we have is -1. So this gives us y minus 3 upon x plus 1 equals to -5 upon 5, which is cancelled and we get -1 on the right hand side, which means y minus 3 equals to minus x minus 1, and we get x plus y minus 2 equal to 0 as the answer to this question. Yeah, answer is x plus y minus 2 equals to 0. Now we have the slope intercept form. The equation of a line having slope m and intercept c on y-axis is this equation, y equals to mx plus c. Now would we define intercept as the distance from the origin? So this is basically the distance, and let's see the question. Find the equation of a line with slope equal to -1 and cutting off an intercept of 4 units on negative direction of y-axis, which means we have this equation y equals to mx plus c, where 4 units is the distance on negative direction, which means the value of c would be -4, and we have the value of m as -1. Putting the values, we get this is equal to minus x minus 4. So we get the answer as x plus y plus 4 equals to 0. We bring x and 4 from right hand side to the left hand side, and the answer is x plus y plus 4 equals to 0. Now we have the double intercept form. The equation of a line making intercepts a and b on the x-axis and y-axis is x upon a plus y upon b equals to 1. So find the equation of a line which cuts off an intercept 4 on the positive direction of x-axis, means we'll be taking it as 4, and intercept 3 on the negative direction of y-axis means we'll be taking as -3. So we have the equation double intercept form, that is it is not x upon y, it should be x by a plus y upon b equals to 1. Now let's put the values. We have x upon 4 plus y upon minus 3 equals to 1. Or you can write this as x upon 4 minus y upon 3 equals to 1. Taking LCM as 12, we have this 3x minus 4y equals to 1. Solving it further, we directly get the answer as 3x minus 4y equals to 12. That's your answer. Moving ahead, this is the general form. The general form of equation is of the form ax plus by plus c equal to 0, where a, b, c are the real numbers. Now, the condition for the parallel lines. Two lines, when we are given the slopes m1 and m2, they are parallel to each other if the slopes are equal. Now, let's have this question. Find the equation of the line which is parallel to this line 3x minus 2y plus 5 equals to 0, and this passes through the point 5 minus 6. Firstly, what we'll do is we'll find the slope of this line, and obviously the slope of this line has to be equal to the slope of the line which we want, because these are parallel, so slopes are equal. So we can write this as 2y, putting 2y on the right hand side, we get 2y equals 3x plus 5. So y would be 3 by 2x plus 5 by 2. So we can straight away now write the slope of this line as 3 by 2. Now this is equal to the slope of the line which we want. So now the line passes through the point 5 minus 6. Let us use the 1 point form which uses the slope as well as the point to find the answer. So we can write y minus y1 equals to m into x minus x1. So this gives us y minus, we have the point x1 y1. So this would be y plus 6 equals to 3 by 2 into x minus 5. This gives us the equation. We can solve it further. 2y plus 12 equals to 3x minus 15. Now we can transform. So this becomes 2y minus 3x plus 27 equals to 0. So that's your answer. Find the next one. Find the equation of a line parallel to the line passing through the point 5, 7 and 2, 3 and having an x-intercept as minus 4. First of all, just observe, this is having x-intercept as minus 4. It means this line passes through the point minus 4, 0. Because we have just defined intercept as the distance from the origin. So minus 4 units is the distance, which means this particular line will pass through the point minus 4, 0. Now, we are given 2 points, 5, 7 and 2, 3. So we'll find the slope. So slope of this line would be, using the formula y2 minus y1 upon x2 minus x1, we'll get this as 3 minus 7 upon 2 minus 5, which is equal to minus 4 by 3. This is the slope of the line, and this line passes through the point minus 4, 0. Now we find the equation, which is by using this y minus y1 equals to m into x minus x1. So we'll use this y minus, we have the point x1 y1 as minus 4, 0. So y1 is 0. So y minus 0 equals m we have is minus 4 by 3 into x plus 4. So this would be 3y equals minus 4x minus 16. Okay, just a minor change. This was 2 minus 5, which would be minus 3. So slope would be 4 by 3 and this cancels. So there would be no negative sign. So this becomes 3y equals to plus 4x plus 16. So that's your answer. Yes, 3y equals to 4x plus 16. So now the condition for perpendicular lines. Two lines whose slopes are m1, m2 are perpendicular if their product is -1. So find the equation of the straight line passing through the point 3, 4 and perpendicular to the line 3x plus 2y plus 5 equal to 0. We'll first find the slope of this line. So we can write this as 2y equals to minus 3x minus 5, which gives us y as minus 3 by 2x minus 5 by 2. Hence, the slope of this line is minus 3 by 2. Now, the equation of the straight line we want is perpendicular to this line, which means the product of these two slopes, the slopes of these two lines is -1. Hence, the slope of the other line which we want is 2 by 3. And that particular line passes through the point 3, 4. So, using the formula y minus y1 equals to m into x minus x1, we put the value. So it's y minus 4 equals to 2 by 3, which is the value of m, into x minus 3. So we get 3y minus 12 equals to 2x minus 6. So bringing 2x minus 6 on the left hand side, we get 3y minus 2x minus 12 plus 6 equal to 0, or we can write 3y minus 2x minus 6 equals to 0. That is the answer to this question. So we are given angle between two lines. If the equations of the two lines are a1x plus b1y plus c1 equal to 0 and a2x plus b2y c2 equals to 0, then tan theta is given as a1b2 minus a2b1 upon a1a2 plus b1b2. Find the angle between these two straight lines. First of all, let's write the formula and then we'll proceed ahead. So tan theta, from the previous slide, we'll write this as tan theta equals a1b2 minus a2b1 upon a1a2 plus b1b2. This is the formula. Now, after going ahead with the formula, let's first transform these two equations in this form b1, b2. So, we can write the first equation as 2 minus root 3 x plus 5 minus y equals to 0, and similarly 2 plus root 3x minus 7 minus y equal to 0. Now let's put the values. So a1 would be 2 minus root 3, b1 would be minus 1, a2 would be 2 plus root 3, b2 is also just like b1, this is also equal to minus 1. Now let's put the values in the formula. So we have a1 into b2 gives us minus 2 plus root 3 minus a2 into b1 is minus 2 minus root 3 upon a1 a2. This is 2 minus root 3 into 2 plus root 3, that would be 1 plus b1 b2. We can observe this minus 1 into minus 1 gives us 1. So this is also 1. Solving it further, we'll get minus 2 plus root 3 plus 2 plus root 3 upon 2. So minus 2 and plus 2 get cancels. This is equal to root 3, and obviously this is the value of tan theta, which is coming out as root 3. Hence we can say that theta equals to 60 degree, because tan 60 is root 3. This gives you the answer as 60 degree. Now two more formulas. One is perpendicular distance of a point from a line. So if this point P is any point and perpendicular distance is given as ax1 plus by1 plus c upon a square plus b square in the square root, and finally their modulus. Similarly, the next thing, if this point P's origin, that is x1 and y1, are basically 0, 0, then the formula changes to c upon a square plus b square square root. Now we have this question: find the distance between this particular line and the point 2, 1. So using the formula just discussed in the previous slide, we will write 12 into 2 plus, we have minus 5 into 1 plus 9 upon 12 square plus 5 square root in the modulus. This gives us 24 minus 5 plus 9 upon 13, which gives us answer as 28 by 13. Let's move ahead. Now, this is the perpendicular distance between two parallel lines. Obviously, for parallel lines, we know slope are equal. So, ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0. Obviously, the constants are different and the coefficients a and b are same in both the lines, and the perpendicular distance between these two lines is given by the difference of constants upon a square plus b square square root in the modulus. So, let us find the perpendicular distance between these two parallel lines. So, using the formula just discussed in the previous slide, we have 12 minus 3. You can observe this is value of A, this is the value of B, and this is C1. Similarly, A and B are constant, which are 3 and 4, and this would become C2. So, we'll have 12 minus 3 upon 3 square plus 4 square in the square root gives us directly 9 upon 5. Find the equation of a circle with center at 3 minus 4 and touching the line 5x plus 12y minus 12 equal to 0. So, we know if the circle has a center at hk, then the equation of the circle is x minus h whole square plus y minus k whole square equal to r square. So, we are given the center 3, 4, that means 3 and minus 4, that means we have the values of h as 3 and k as minus 4. But we don't have the value of radius. So let's visualize this question. Now you can observe we have C as the center given as 3 minus 4 and the line 5x plus 12y minus 12 equal to 0. This touches the required circle at P. Now definitely this CP would be perpendicular to this line, or you can say this line would be acting as a tangent to the circle, and obviously the distance CP is the radius. Now we need to find this perpendicular distance because the value of r needs to be calculated. So basically the radius CP is nothing else but length of the perpendicular from this point 3 minus 4 to the given line, and using the formula we can get this radius. Just the formula discussed in the previous slide, we get the radius as 45 by 13. It is 5 into 3 and 12 into minus 4 minus 12, using the formula directly. So the circle has its center at 3 minus 4 and radius as 45 by 13. So now you can find the equation. So this is x minus 3 whole square y plus 4 whole square gives us the answer as 45 by 13 whole square. Now we have some practice questions for you. This is the first 2 questions, 3 more questions, and these are the answers. For more videos, you can obviously log on to our website hitbullseye.com. Thank you.